So, can do a quick review of yesterday. So we have this expression, 9 to the power of 2x plus 3 divided by 27 to the power of 3x minus 1 times 81 to the power of x minus 1. We're going to combine this all together. Okay? Now, as is, we can't do anything with it because they all have different bases. Correct? If we combine, use our log rules, our exponent rules, we need to have the same base. So what is a common base for 9, 27, and 3? In other words, what number can I make? What am I trying to say here? What number to a certain power will give you 9, 27, and 81? 3, right? So for the 9, I can write 3 squared, and the 2x plus 3 is there, divided by 3 to what power is 27? 3. 3 cubed, 3x minus 1, times 3 to the 4, x minus 1. Okay, now we have them all in a common base. So we can use our exponent rules. If you are dividing, what do you do with the exponents? Subtract them. So we can go 3. Actually, you know what? We know what the base is going to be. Let's just deal with the exponents here. So the exponents is going to be 2 times 2x plus 3 minus 3 times 3x minus 1. And if you're multiplying, what does that mean? You're doing with the exponents. You're adding. So then we can just go plus this bit. These are all the exponents. Essentially, this is 3 to this power. Is everybody on board with that? Does that make sense? Okay, now it's just algebra on the top there. So I'm going to expand all this and then collect like terms. So 3 to the power of 4x plus 6 minus 9x plus 9 plus 4x minus 4. Yeah, why did I write plus 3? It's a good question. Or plus 9, there you go, thank you. Plus 3. 3 times 1 is 3, not 9. Okay, collect your like terms. 4x and 4x is 8x. Minus 9x is negative 1x. So just negative x. 6 plus 3 is 9. Minus 4 is 5. So it's 3 to the power of negative x plus 5. Or you could flip them and write 3 to the power of 5 minus x. I don't really care. It's your choice. Is that okay? All right, that's what we did yesterday, but we kind of made it slightly more complex, but same ideas. Okay. You go down to the bottom here. Are we okay? Are we okay? Yeah. All right. Now, we're going to start solving questions. You haven't done that yet. What we did yesterday and what we did at the beginning of class was the variable is in the base. You had a weird exponent, whatever. Okay. We didn't have a variable in the exponent. When you have variables in the exponent, as you're going to see in lesson 3, these are called exponential functions. Okay. but we're going to start solving these. So if I have, just as an aside, if I have 5 to the power of x, and I say that equals 5 to the power of 2, what does x equal? 2, right? Does that make sense? It has to, right? If this is essentially what it's saying is 5 to the power of x is equal to 25, what number of x will make it 25? It's 2. But what you do is when you have the bases the same, you forget about them, they're irrelevant, and you just try to make the exponents match. We've already made these match, we just have to make the exponents match. Okay? That's what you do for all these. So in the first one, we have 5 to the power of 2x plus 3, 5 to the power of 7. Are the bases the same? Yes. If the bases are the same, you ignore them, and you just deal with the exponents. So 2x plus 3 is equal to 7. And then it's just algebra. Move the 3 over. 2x is equal to 4. So x is equal to 2. And what should you do on a test, quiz, in your head, whatever, just to be sure? Plug it back into the equation. If I put 2 into here, what's 2 times 2? 4. What's 4 plus 3? Does 7 equal 7? Then we're good. Okay? I'm not going to give you marks for checking your answer. That's on you. It's a good idea. All right. B. 7 to the power of x minus 2 is equal to 343. What's wrong with, well, it's not wrong, but can we do anything with it as is? You need to make it a common base. The bases need to be the same. So your question is, this is base 7, that's a prime number. Can't change that. Can I make 343 into base 7, i.e. 7 to what power is 343? So I changed the 343 to 7 cubed. Once the bases are the same, you just with the exponents. So it's x minus 2 is equal to 3. So x is equal to 5. All right. Next one. What do I do? Same base, which is 3. Because you can't make 3 anything else, right? So 3 to the power of 5x minus 1. 3 to the 4 is 81, and there's a 3x there. Once the bases are the same, you lose them, and you get 5x minus 1 is equal to 12x. Algebra it. We're turning algebra into a verb. Just leave it as a fraction. Don't write it as a decimal. Negative 1/7 is perfect. We okay so far? All right. D. What base am I going to make things? 3. You need to make this base 3 and this base 3. So I'll get 3 to the power of x. 27 is 3 cubed. What's root 3 in base 3? If that makes any sense. How do you write root 3 as an exponent is what I'm saying. 1 over 2. Okay. 3 to the power of 1 over 2. Is that what you said? Dawson? Oh, sorry. Okay. You can't equate them yet. You have to make it 1 base equals 1 base, just like all these other ones. 1 equals 1, 1 equals 1. This is 2 different bases. So what do I do with these exponents to make it 1? Add them. So 3 to the power of is 3. Now you could do a decimal. I'll vomit a little bit if you do, but that's okay. But you can combine them. You're going to make it a common base. So you get 3 to the 7 halves. I'll say 4. So what does x equal? 7 over 2 or 3.5? Is that okay? All right, we're going to flip the page, please. I'm not doing this bacterium thing. I'm going to do these guys. Look at these fun things. All right. So is there any difference between these and what we did in the other page? Other than they look ugly, because they have fractions. There's no difference. Okay. Thing is, this side is not a fraction. Fraction. But you can make anything a fraction or get rid of the fraction by doing what? Flipping it and making the exponent. Yes. Exactly. That's it. So, do you want to deal with fractions or do you want to deal with no fractions? That's usually what people say. So we're going to change this to no fractions. What do I do? Okay, so 27 x minus 2 is equal to 81 to the power of negative x plus 3. Wow. So it's the negative exponent. Now what do I do? Same base, 27 and 81. What's common base? 3. So 3 to the power of 3, 27. 3 to the power of 4, so I'll make that negative 4, is 81. Now what? Yeah, lose the bases, equate the exponents. So I get 3 x minus 2 is equal to negative 4 x plus 3. FOIL or distribute it. 3x minus 6 is negative 4x minus 12. Put your like terms on one side, so 7x is equal to negative 6. Negative 6 over 7 is your x value. Is that okay? All right, last one. We have fractions. We're going to have to deal with them. That's okay. So, 6 over 5. I cannot reduce these to any other base, right? There's no number. There is. You can reach 6 squared, but nobody wants to do that. Let's see, 5. So this is my kind of the lowest you're going to go. So I need to make this 6 over 5. What's the problem with that? Looking at this fraction. Is 125 can be made into base 6? No. 216 can, and 125 can be the base 5. So I need to flip this fraction. When you flip a fraction, what happens to the exponent? It becomes negative, but in this case, it's already negative, so it'll flip to positive. So we flip that first. So 216 over 125 becomes, it's negative of negative x over 4, so we can just write x over 4. Now what? Same base. So we're going to need to make it in base 6 over 5. Don't worry about the base 6 over 5. All you got to do is look at 1, the top or the bottom. All right? So we'll do with the 125. 5 to what power is 125? 3. And then just check it with the other one to make sure, because they need to match. Otherwise, it's, like I said yesterday, a different problem. Is 6 cubed 216? It is. So this here, you can rewrite it as 6 over 5 cubed. That'll give you 216 over 125. And remember, there's this x over 4 hanging out on the outside. Bases are the same. What do? Exponents. 3x over 4, 3x plus 3. And then you algebra it, multiply the 4 up. Reduced value would be 4/3. 12 over 9 is fine, but you want to reduce it down. How is that? Is that okay? All right, make them the same base, equate the exponents. 2, 3, and 6, please. I mean, yeah. Probably won't get them all done, but that's okay. For now, at least do a few from each question. You can pick up the rest tonight at home. We will talk about the tests today. Class average was like 82%, which is actually really good. But we'll talk about that more later on. 2, 3, 6, please. Humans, work on those, and then we will go on to lesson number 3. Did everybody get the email I sent home with the test results? So all good with that? And can you see your overall grade on there? No? You're supposed to be. I checked the box that said you can see your overall grade. Like actually in the class, current grade in the class. I'll check that.
Yeah, you can check it.
You can?
Yeah.
Okay.
It's just like you have to click on the little like line thing.
Oh, okay. The menu?
Like
the menu?
No, it's like I don't even know what it is.
Oh,
But,
no.
like it's like a little person in like a box. Like it's like a little box with a person.
Okay. Check on the little person in the box thingy, and then you can see your current overall grade.
Yeah.
Probably stop the video.